Here we go with a little more of the algebra review. Most of the stuff should be things from Algebra 1, but we are kind of cramming it all into one section. So please let me know if you have questions about these. This is meant to be review. It's not meant to be seen for the first time. If you are happen to be seeing this for the first time, please let me know and I can help you out with it more in depth. So there's two types of equations of lines that we're going to be looking at for the sake of this class. We are not going to really be using standard form, so if you remember that, that's fine, but we're going to be looking mostly at slope-intercept form and point-slope form. The slope-intercept form you need to remember is y equals mx plus b, where the number here, m, stands for your slope, and the number here, the b, we say is the y-intercept. The other form is one that I like a lot, and depending on your algebra experience, you may have used this a lot and you may not have, but I really prefer point-slope form, which is y minus y1, and that equals the slope times x minus x1. I like this a lot when you're given a point in the slope. I will always use slope-intercept form when you're given the slope and the y-intercept, but most of the time you're given a point and a slope, and I prefer to plug things in here. You could also plug them into slope-intercept form and solve for b and then rewrite the equation. So if you're used to that and you would like to do things that way, that would be fine, as long as you're able to write the equation of the line. So let's get to some examples and I'll kind of show you what we're going to be doing. For this example here, it simply says write the equation of the line with a slope of -4 and a y-intercept of 5. So when they give you those things, you can simply plug them into slope-intercept form and just write that y equals -4x plus 5. And then if the directions ask you to graph it, what you would do is you would start at the y-intercept, so in this case start at 5, and the slope is -4, or think -4/1, so you can count down 4 and over 1. And you could just do that a couple of times till you see where that line is going to be. And then you would have your, whoa, that line is really thick. Then you would have your line. For this one here, it says write an equation of the line with a slope of 2, and it goes through this point. So this is where I would use point-slope form. So y minus the y value equals the slope times x minus the x value. So you're going to plug the slope in here for m, and you're going to plug your coordinate in for x1 and y1. So this would be y minus, the y value is 7, equals the slope, which is 2, times x minus the x value is -3. So the only thing you need to make sure you keep in mind here is this would be adding the opposite. So I'd probably actually just write this out. Y minus 7 equals 2 times x plus 3. So if the directions just ask for an equation of a line, technically this is the equation of a line. It's just written in point-slope form. So really you could be done at this point. If they want you to write it in slope-intercept form, then you'd have to go through and solve for y. So if that were the case, I would distribute the 2, and then I would add over the 7. So y equals 2x plus 13. If I were to graph this on this coordinate system here, I would have a hard time graphing this unless I changed the scale, because it just doesn't go all the way up to 17. However, I can still graph this even without changing the scale, just by going back and looking at like what this original information says. So the point -3, 7. So -3, 1, 2, 3, 4, 5, 6, 7. And it has a slope of 2. I was having this problem earlier. And it has a slope of 2. I can't go up 2 and over 1, but I can count that backwards and go down 2 and to the left 1, down 2 and to the left 1. And then from here I can make my line. Then you could see that if this line were to continue up, it would eventually intersect at that positive 13. You can really graph it based on the information they give you or based on slope-intercept form like you're probably used to having in Algebra 1. Both of them, though, should make sense with each other. Both of them are correct. So again, if the directions don't ask you to, you could just leave things in point slope form. If they want you to rewrite, this would be slope-intercept form. In this third example, what we're asked to do is write the equation of a line, and it just tells us the 2 points that it goes through. It doesn't give us what the slope is. So when that's the case, you need to make sure that you calculate what the slope is first, because for either equation, no matter which one you're using, you have to know the slope. So when I calculate the slope, I subtract those y values. So -9 minus -7, I'm going to end up adding the opposite. And 0 minus 4, this is going to be -2 divided by -4, which when I simplify it, I get a positive 1/2. That is my slope. So I have some different options here as to how I could set this up. You could use point slope form, and that's, again, what I said I prefer. I would set this up as y minus, and I would pick either one of these values here to be my slope or my point. Let's just go with this first one and see what happens. So y minus -7 equals the slope, which is 1/2, times x minus the x value, and in this case the x value is 4. So when I rewrite this, this is going to be y plus 7 equals, and I'm just going to go ahead and distribute at the same time, 1/2 x minus 2, and then I can subtract 7 from each side, so y equals 1/2 x minus 9. And I did this on purpose. I actually noticed something, and maybe you kind of notice it now, but this -9 is actually told to me in a different form. This doesn't flat out come out and say -9 is the y-intercept, like that first example does, but this coordinate, 0, -9, if you think about 0 being it's not going left or right at all, -9 would be the y-intercept. So if you have a 0 first as your x value for a coordinate, whatever that y value is, that's going to be your y-intercept. So that might be a way to make kind of a shortcut out of some of these. It won't always work out all of the time, but I just want to point that out to you here. Either way, though, you can pick either point and plug it in. Again, I like to plug it into point slope form, and then you can go ahead and solve for y if you need to. A couple of special examples here. We do have horizontal and vertical lines, and those equations don't look the same as like y equals mx plus b. For a horizontal line, the equation will be y equals just whatever b is. And the reason for that is if you think about it, it'd be y equals, for a horizontal line, remember the slope was 0. So y equals 0 times x plus b. Well, 0 times anything is 0. And so instead of just writing y equals 0 plus b, they're just going to kind of shorten that up and just write y equals b. The only one of these that is not a function is the vertical line. And a vertical line is written in the form x equals some number. Like in this one here, it's just x equals -2, and that's the equation for that vertical line. So let's look at these couple here, and I'll kind of show you what those will look like. So what I want to do first is I want to calculate what the slope is. So the slope is the difference of the y values, so 8 minus -5, and then 3 minus 3. When I add the opposite, this one ends up being 13 over 0, which is an undefined slope. So that would just kind of suggest to me that this is going to be a vertical line. And vertical lines, remember, are written in the form x equals whatever the x values are. So in this case, the x value for both of these is 3. So my equation of this line would simply be x equals 3. For this one down here, I'm going to calculate the slope. So the slope is the difference of the y values. So -7 minus -7. Make sure you add the opposite. And -4 minus -2, again adding the opposite. This one here, you end up with 0 divided by -2, which remember 0 divided by anything is simply 0. So since this one has a slope of 0, this one here actually could be written out with point slope form and just plug in 0. But I remember that if a line has a slope of 0, it's going to be horizontal. So I can simply just write out that the equation is going to be y equals whatever those y values are. So in this case, it's -7. And that would be my final answer for this special situation here. You may notice these special situations, and you'll notice them when like the x values are the same or when the y values are exactly the same. If one was +7, the other one -7, it wouldn't be the case. But if they're the exact same number, it's going to be a special type of line, either horizontal or vertical. There are kind of a lot of examples here, so we'll just kind of keep moving on. For this one, it says write an equation in slope-intercept form for a line that's perpendicular to the line y equals 3x plus 2 and then contains this point. So the fact that it's perpendicular to this line is really important. And the thing that's really important here is that we investigate what the slope is. So the slope of the line that they give me is -3. And if you remember from the last section, perpendicular lines, their slopes are opposite reciprocals. You'll need to remember that in order to do this problem. So since the slope of this line is -3, if I think about what the opposite reciprocal slope would be, it'd be a +1/3. So opposite would be positive to negative, negative to positive, and reciprocal just means that you take that fraction and you like flip it upside down. So the slope of the new line is 1/3, and it contains the point 0. So now I have everything I need to write the equation. They want the equation in slope-intercept form, so if you would like to plug it into point-slope form, you just have to do a little converting at the end. So y minus the y value equals the slope times x minus the x value. And here, subtracting 0, that's really just going to kind of go away. So y equals 1/3 x and then minus 4/3. You'll just need to kind of get used to the fact that these won't always be just nice whole numbers. If you would like to change that to be -1 and 1/3, that would be the same thing. Usually you'll see I'll just leave them as fractions or improper fractions though. But that notation would be just up to you. Okay, and for this last one here, it says write an equation in slope-intercept form of a line parallel to this line containing that point. So if they're parallel lines, you need to remember that parallel lines, the slopes are the same. So the slope of this line is -3/4. The slope of the new line will also be -3/4. And it contains the point -3, 6. So I'm doing the same thing. I just have this little bit of background information I need to come up with first, and then I can plug it into point slope form. So y minus the y value equals the slope times x minus the x value. And I got to add the opposite. This one here, I have a little more work to figure this out. I'm going to distribute that 3/4. And this is going to be -9/4. Remember, when you're multiplying fractions, you just kind of multiply the numerators and the denominators together. Then I'm going to add 6 to each side. So y equals -3/4 x, And you could use your calculator to do this if you can't do it without a calculator, but just a quick little review on how to add these things together. What I would do is I would think about like how many fourths is equivalent to 6. So 6 is the same thing as 24 fourths, because 24 divided by 4 is 6. And then I'm just adding the negative 9 fourths plus 24 fourths. So that would get me a positive 15 fourths. This section ends with a story problem. I'll kind of go through it quickly with you. I am not going to take the time to get out the graph paper and to do all of this stuff with these decimal slopes. That's not going to be as important. It's just kind of the concept behind this. So I just copied from the book the actual graph so we could talk about what's happening here. We have these phone plans. And you guys' phone plans probably are just unlimited. But before everybody just had unlimited, you usually paid a certain amount and then paid per minute after the fact. So this kind of outlines some different plans like that. So we have Plan X, and that cost $39.95 per month for unlimited calls. And then, oh, in this case, it's so much per text. You guys would probably be in big trouble if you had to pay 5 cents for every text that you sent. But it used to kind of be like that. So let's go over these. The cost of this first plan. So I'll write over here, Plan X. The cost per text would be kind of like your slope. So they're using C instead of Y, and that doesn't really matter. It would be 5 cents, and they use T for text instead of X, but again, that doesn't really matter. And then it's plus that $39.95 just set rate. And then you have Plan Y. And Plan Y costs less per month, but then they charge 10 cents for every text. So Plan Y, the cost is 10 cents a text, but only $35 per month to begin with. So the question's asking here, which plan offers the better rate? And that's just not like a one answer fits all type question. Because if you weren't going to send any texts, Plan Y would be the better rate because that would only cost the $35 per month. But if you were going to send a lot of texts, like for probably most of you guys, you would want Plan X because then it's less per text. So what they have here is they have these different plans outlined. This one here that starts low, this is Plan Y. This one here that starts a little higher, but then the slope's not as steep is Plan X. And it shows you here that the plans, let's see, it appears that for 100 text messages, the cost of the plan is the same, about $44. So your answer would have to include something like this, but then say like which offer or which plan offers him a better rate. You would have to say, well, it depends on how many texts he sends. You know, if let's see, his name was Benito sends less than 100 texts, then Plan Y is better. But if he sends more than 100, you know, he should go with Plan X. And your answer should include something like that. The way that you could figure out this exact point, this exact intersection, would be to set up a substitution algebra problem with this system of equations. You want to see when these two things are equal. So what you could do is you could set up 0.05t plus 39.95 and set that equal to, 0.10t plus 35. And you could go through and solve this. for t to figure out that exact intersection. So we have 0.05 t and 495. So if I just go ahead and pull up a calculator here, 495 divided by 5/100, it's 99. So actually here, this should be, it says for 100 texts. This would actually be for 99 texts would be your actual number where they would be exactly the same. But you get the idea. It would totally depend on how many texts you were sending per month. I might actually be able to get away with the plan Y, but I'm sure most of you guys would be here at plan X if these were your two options.